Today we're going to graph piecewise functions and evaluate them for specific x values. So looking at our first example, we have f of x equals the square root of x. Okay, and remember square root, that just makes, I call it a little check. It's like half of a sideways parabola shape. And we're going to graph this when x is greater than 1. We have f of x equals x squared minus 1. We're going to graph that between -2 and 1 and including both of those points. Remember, x squared makes the parabola. The other shape we're going to have, which isn't on this graph, is an absolute value. And remember, absolute value, that makes a V shape. Okay? And then our last graph is -2. Well, that's just going to be a horizontal line. So when it's just a number, that's going to be a horizontal line at x is less than -2. Okay. So what I'm going to do is just start with the first function. So the square root of x minus 1. Okay. Now even though this doesn't have an or equal to, we're still just going to start at 1, but we're going to put an open circle at this point since it doesn't have the or equal to. Okay, so you don't want to skip over 1 and start at 2 because then you're missing like the 1.1, 1.2. So still start at this x value, just put an open circle there. Okay, and then I'm going to plug in the numbers bigger than 1. So normally I would just count up in order, but since this is a square root, I'm only going to plug in the numbers that give me perfect squares. So like when I plug in 1, that's the square root of 1 minus 1, which is square root of 0, which is 0. Okay. So I'm looking for the numbers that are going to give me square root of 0, square root of 1, and square root of 4. Those will be the easiest points to graph. Okay, so by plugging in 1, that gives me square root of 0, which is 0. So I'm going to go ahead and graph the point 1, 0 with an open circle. Then if I plug in 2, 2 minus 1, that'll give me square root of 1, which is 1. So then I'm going to graph 2, 1, and everything after this will be a closed circle. Okay? You only put the open circles at this specific x value. Okay? Then in order to get 4, I would have to plug in a 5 for x. So that's 5 minus 1, square root of 4, which is 2. Okay? So that's going to be 1, 2, 3, 4, 5, up 2. Okay, so this tells you the value to start at, so we start at 1, and since it was greater than, I started plugging in numbers bigger than 1, and then these would just continue to get bigger and bigger, so I put an arrow on that right end. Okay. Then that second equation, that's x squared minus 1, and this time they tell us to graph everything from -2 to 1. So I'm just going to plug in all the numbers between -2 and 1. So this will be -2 squared, which is 4, minus 1, so 3. So I'm going to have a point at -2, 3. Okay, these are both going to be closed circles, so I won't have any open circles on this section. Then when I plug in -1, -1 squared is 1, minus 1, that'll give me 0, so 1, 0. When I plug in 0, 0 squared is 0, minus 1. So when x is 0, the y value is -1. And then when I plug in 1, that'll be 1 squared, which is 1, minus 1, which is 0. Okay. So now anytime it's a double inequality, you're not going to put any arrows on your graph. You're just going to connect all of those points. You're going to start here, stop here, not go past anything. Then our last graph is -2. So no matter what x is, so I'm still going to start at -2. This is x is less than -2, so I'm going to plug in the numbers less than -2. Okay, so unless it's a square root one, I just count in order. Okay, so no matter what the x value is, the y value is always going to be -2. And this first one right here, the point at -2, because that's the x value in the inequality. So since it doesn't have an or equal to, this point, the negative 2, is going to be an open circle, but everything past it is going to be closed. So we're going to start here and go to the left and put an arrow at the end. So you're always going to have arrows on the very right and the very left end, with one exception, which we'll go over next. So here's our graph. We're also going to want to find the domain and range. So domain is x, so that's left to right. So this graph goes to negative infinity, okay, because it has an arrow on the left end. Okay, it stops at negative 2, but this one picks up right at the same point. So if I were to take this graph and flatten it along the x-axis, this circle would fill this one in. So where this one stops, this one picks up, and then it keeps going forever to positive infinity. Now for our range. Range is y, so that's bottom to top. So if I look, this is the lowest that it gets. Okay, so this lowest value is negative 2. Now even though it's an open circle here, if I look here, these are solid points. So negative 2 is included in the range. So we will put it in a bracket. Okay, and then if I look, there's a gap here. Okay, there's nothing connecting this negative 2 to another negative 2 on the y-axis. So negative 2 is just all by itself because it's just this horizontal line, and then there's a gap before the rest of the graph picks up. So we're going to put negative 2 by itself, then we're going to put a u to connect it to the next interval, and then where it picks up again is this is the next lowest point. Okay. Well, that y value is negative 1. Okay. And then if I look here, there's an arrow over here. Now, so even though this graph is flattening it out, it's still getting higher just little by little. So eventually this is going to go all the way up to infinity. It's just going to get there very slowly. So since there's an arrow on this right end that's getting higher, that means our y values will get to infinity. So that second interval is going to be negative 1 to infinity. Now let's look at one more example. So we have f of x equals 3 minus x when x is less than or equal to 0. So remember, this is just a line. If it's just an x to the first, that's just a linear equation. So I'm going to do this graph first. I look at the inequality. That tells me to start with x equals 0. And so since this is less than or equal to, I'm starting with a solid point here. And I'm also plugging in the numbers less than 0. So I typically just do like 3 points. And again, it's not a square root function, so I just counted down in order. So if I plug in 0, 3 minus 0 is 3. So we're going to have a point at 0, 3. It's going to start with a solid point because this has the or equal to. Then I'm going to plug in negative 1, 3 minus a negative 1. That'll be 3 plus 1. So I'll have negative 1, 4. And then plug in 2. 3 minus a negative 2 is 3 plus 2. So this little section of the graph is going to start here, and then it's just going to keep going to the left forever. Now this second one, we've got the square root of 4 minus x when x is greater than 0. Okay, so I'm still going to start at 0. Okay, but since this doesn't have the or equal to, I'm going to put an open circle at this point. So if I plug in 0, that's going to give me square root of 4, which is 2. So I'm going to have an open circle at 0, 2. Okay. Then if I plug in 1, that would give me square root of 3, so I'm going to skip that. If I were to plug in 2, that would give me square root of 2. But if I plug in 3, that's going to give me 4 minus 3, square root of 1, which is 1. So I'm going to have a point at 3, 1. Everything else after this point will be closed. If I plug in 4, that's going to give me square root of 4 minus 4. Square root of 0 is 0. Okay. And on these square root ones, okay, normally we would connect these, and since it's greater than 0, we would normally put an arrow at the end. Okay. But when you're graphing the square root one, if you're making a table, if your square roots are decreasing, like this is going square root of 4, square root of 1, and then we got to square root of 0, when you get to square root of 0, you're going to want to stop your graph here. We can't go any farther. If I were to plug in 5, that would give me square root of -1, which is imaginary. So on the square root functions only, you're not going to put an arrow at the end if you get to square root of 0. So if we look at this last one, on the square root function, our square roots were getting bigger. We started at square root of 0 and then we went up to square root of 4. So that meant we can keep going because the square roots are just going to get bigger. Here, since I got to square root of 0, since my square roots started getting smaller, that's when we have to stop. Okay, if you're not sure, just plug in the next number. You'll see it'll give you the square root of a negative. That will tell you to stop your graph. Okay. So then our domain, okay, on the left side we've got negative infinity, and infinity always goes in a parenthesis. Okay. And then even though it stops here at 0, this one picks up, and then it goes to 4, but it doesn't go past 4. Okay, we had to stop our square root graphs because otherwise it went into the negatives. Then my range, I'm going to have to do 2 parts again because I have a gap here along the y-axis. So this is the lowest point, which is 0, and then it goes up to 2, which has an open circle. So that's going to be a parenthesis. And then it picks up again right here at 3. And then it goes forever up to infinity, and infinity always has a parenthesis, and that'll be our domain and range. So last thing we're going to do is very simple. We're just going to look at plugging in x values. So they've given us some piecewise function here, and we want to find each of the following. So f of 1, all we have to do is pick out which of these 3 functions to plug it into. So you look here, so f of 1, I can see 1 is included in both of these inequalities, but the middle one is the only one where it's equal to 1, because it has the little or equal to. So I'm using this equation. So f of 1 is just going to be 4. Okay. So for f of 6, so these little values right here, these are the x values. So you're looking to see which inequality it falls in. So 6, that's greater than 1, so I'm going to use this equation right here. So I'm going to plug in 6 for x. That'll give me the square root of 6 plus 3, which is the square root of 9, which is just going to be 3. So then for f of -3, that falls in this inequality. -3 is less than -1. So I'm going to do a -3 squared, so make sure you square the number first, then multiply by a negative, then add 2. So -3 squared is 9, times that negative is going to be -9 plus 2, which is -7. Okay. Then f of 0, 0 falls between -1 and 1. So I'm going to use this equation here, which is just 4, no matter what x is. And same thing for this last one, f of -1. Okay, so you can see the -1 in both of these inequalities. You pick the one that includes it, which is again this middle function, which would just be 4.